It has been a privilege and honor to have been taught my trade, which built my skilled career by the sacrifices and with the integrity of all the veterans, my supervisors, other journeymen, and fellow apprentices during my 15 years in naval ship repair. The time shared with the active duty personnel working together to keep our fleet in tip top shape encouraged my understanding of why we are a nation with freedom and open dreams that can be reached with our own hard work. Ladies and gentlemen, welcome to my job shop. My name is Keith, and I'm here repairing America one project at a time or building something new like the radar mast that we got set up here now on the milling machine. Yep, look, got a hole in there. Okay, I'm looking in at this weld right now, and I'm looking at the cross section that I just milled right there. That's 100% weld penetration. You can see the penetration through on the backside down in that tube there. And then let's come around to this side here, and you can see the same thing. And you can even see down along the wall around the other side there, you can see the penetration there. Let me back out just a little bit, get a little clearer. Okay. There's the mill point still hanging on there. Yeah. Okay, so we're happy with our penetration and this opening for our insert that's going to lead the wiring into this portion of the spreader. When we turn this back around and to punch a hole in the backside of the spreader, the V shape is in the other direction, and we had to put in these 1-inch spacers here to get over those 3/4 holes, uh, 3/4 bolts, 3/4 head bolts, and they stick up about 3/4, so we got 1 inch here. The hole pattern in this is not conducive to hold down clamps on it and hold it in place. It would be so much easier to go ahead and have a U-shaped channel or something like that to clamp on. So that's what we came up with, was an idea. And we're going to pull our bars off of here. And we had 2 extra pieces of box tube from building the drill presses. And we're going to put a pair of holes in them so that we can get a nut in here and reach in there and tighten them down to the table. And then we'll be able to set this on here. Take our clamps, come on down and clamp the thing and hold it with our bessies like we did in this direction here. A lot of people underestimate the strength of these, and a lot of my jigs I actually use Bessie clamps. From doing struts, rudders, and skegs, and clamping them down with Bessie clamps in the horizontal position here, I've done a lot with them. And they are very, very strong. You got to make sure that they are secure. And also too, when I'm clamping down, I'll set this down just like I had over here. When I was clamping down on one of those rosette welds. I knew I had stiffness underneath, because just outside of that spot weld, within 3/4 of an inch, is the cross beam in there. So you know you're good. You're not going to be squishing that plate. We decided to go ahead and put the seam of the inside of the box down, make up angles for both sides, this one on each side, ran a small bead 3 places on each of the angles there, and the holes are set up for the pattern. Now we can do all kinds of different things with these holes and lining them up with the slots and everything else, but we got maximum strength to actually have them straight in a line. And We did that for future use of these things with other projects that we got at hand. But at least now we got that surface and we can come down and set them down and clamp them. We're going to set the width here so that we know that we're clamping over a support area right here. All right, so we got one right there, and we got one right here. Those are the two that are next to each other. All right. And if you noticed, we actually have it upside down. This is the flat side we need to line it up on. All right. Just like that. Okay. It still has a little bit, it has a little bit of twist in it. Very, very little for its size and what it's doing and supporting. So we're not really worried about, we're not done welding on it yet. So we can also do some clamping and then heat it up and stress relieve it a little bit. But right now, clamping actually brings it down in and brings it to a top position. All right, I like to just find a good position to clamp it in. We know that we're in working range right here as far as the bit. And we take the center line and we square it off of this face. Now, when we did this the last time, we took measurements from this point and this point here down square to the table. And we were 9 1/8 on here and 8 7/8 with this thing perfectly square. So we figured out the ratio between that and this, and we came up with 4.6. So 4.6 ratio of this length right here is really only 54 thousandths that this is. Now, when we first set this up and eyeballed it, we cut out this opening and we shoved that in there, and we kind of went like this till it fit in there, and then we took measurement like that. So for us just to kind of eyeball it and then flip a tape measure end to end, tack it and weld it in there, yeah, it's pretty good. And this is all going to be inside, so it doesn't matter. As long as this wing to the outside shape is all in perspective and lining up, it's good. This will still be welded in, still be structural and all of that good stuff. All right, now we need to clamp it down. We're going to tighten down our 3/4 bolts now, which these are going to be an easier bolt to tighten down than trying to get a box wrench inside that box tube. I want to find center of this tube now that we've locked down and clamped, so that I can come in with my tap follower on my chuck and line it up with the height of the center of this tube here. So all I need is really a machinist square and sharp them. Now don't worry, I know you can't see this face here, but I'm going to put this camera on here now. And we're just going to take sharp them and put it along that edge right there. And we might even go over here a little bit. I don't know exactly where the chuck is, but if we don't have to run the mill table side to side, then all that much better. All right, now it's got to dry for a second. Now we're just going to take our square, set it on the table, and give that corner of the square a place to rub here. Hold the square and come along like that, and you can see the line right there. All right, and I can probably need to dry just a little bit more, but you get the idea, and I've got my mark there. There we go. All right, I came into that line, and I'm good with the scribe line and my pointer. Got our 1/4 inch in there, and that plate is 1/4 inch. And as long as we can sight down on each side of that and it looks good to me, we're gonna call it center. We can also do it by feel, like that. All right, now we can set up and plunge into this rear tube with the same size bit, because where the channel for the wiring is going to be the same diameter. Here we go. I'm going to slow it down, just see if it doesn't make a little difference on the harmonics here. That's a little better on the ears anyway. The Alumitap that I just drip on it keeps the ease of the cut, keeps the cutter from galling, or the aluminum galling on the cutter. Okay, we actually pushed in one of these clamps here, so I'm going to find out a way to lock it from traveling this way here. All right, I'm happy with the center height. That's not going to change, but it is sliding. I can see. See that mark right there? This clamp has been sliding. Okay, I've realigned it. I'll just square off of here. I tap that in. This side here never moved, so I think it's pretty good. I'm eyeballing down in here. It looks really good. like we're still on center. If I have any reasonable doubt when we get in there a little bit, I will take a measure from the plate out to our cutter, plate out to our cutter, just before we get to the bore where we got to go into the plate. You can see I've added 2 of my large vice grips, gripping the box tube and acting like a V-block edge on the back side of there. This is retention, this is retention. So it shouldn't move now. It was cutting pretty nice. It was cutting so nice, it was just, I was starting to stare at it, and actually I could see that it was off that far. You know, a half an inch out here looked like about an eighth of an inch here, and it kind of was visual. I could really see it. All right, let's resume. Looks pretty close to center. I had to get a good look from the side because it sure looks low from the top. Okay, all the way through. All right. We set up our vertical mast in the other room, and we slid in both of our spreaders so that we could take felt marker and mark the holes needing to transfer from the spreaders into these 2 vertical tubes. And now we're set up in here because we're going to bore through and make the matching hole to put in the little sections so that the wire chases will be able to go through. We took 2 parallels, clamped them down here, and we took blocks so that the center line of this tube and the center line of this tube are parallel with each other so that our holes are going to be straight in a line. And then I've taken just spring calipers, or excuse me, spring dividers, and I've set location of where my marks are in relationship to the fin, and then brought it over here and set it to the relationship of the cutter to set it up on center. So we're getting ready to plunge into the first one here. I've got parallels holding it down onto the blocks, and I got V blocks back here, or angle blocks clamped down to keep any pressure this way. We're just going through thin 10 gauge walls, so there shouldn't be that much interference. All right, but we're secure and we're clamped down, so we know that we're not going to grab and throw apart. And actually, you're probably going, "Hey, this guy's clamping shit down with Bessie clamps, and he hasn't lost nothing yet." I have in the past lost something, so don't. That's. I'm very, very careful about where I am, and I pay attention to the part on the table as well as the cut going on. And if you start seeing your part move, there's probably an issue. All right. While this is all set up here square on the table, I'm also able to take my square off the table and square off the palm of this mount. And we'll be coming into this because I'm going to use this setup to also twist, set the palm perfectly 90, which is slightly off, but I knew on my drop line coming down that I was off, and it shows in the same direction of correction. And also too, this thing has been like manipulated when we were taking everything apart, so I didn't trust it anyway. But I tacked it on the forward and aft leaning section so that I can do a twist side to side and it'll be fine. So we'll be coming up to that, and I'll bring in my welding leads, and we're going to weld up the bottom of this thing right here before we pull this up again after we do this hole. Okay, here we go. Alumitap, I do need that. Okay, just never want to be without it. It always kind of like lock the table. All right, here we go. It does have a little bit of harmonic going on here. Okay. The important one is the inside one here. Let's hope we have enough travel. It kind of looked like we did. I'm not going to be able to add any. If we get a partial hole here, I'll be able to rotary burr the other or the rest of it. This is the largest. All right, I can see we're actually starting to come through here. Looking good on my marks. I can feel it shaking my arm. All right, there we go. With our square against the table here, and we're set up on those pipes just like I showed you. And I'm probably about 100 thousandths down in here, gap on the bottom, touching at the top up here. Now we want to twist this. I can, well, I can grab it with my hands and I can get a little clearance on the top and close it a little bit on the bottom, but I need a little bit more strength than that. So let's go ahead and grab, I love these things for grabbing hold of flat sheets and go ahead and tweak this a little bit. and it'll need a little bit more, but I want to check it down here towards the small end because we can take a little tiny bit out of the small end as well. Hi. All right, Sophie Grew stopped by to let us know that she got her driver's license, and so you want to be a little extra careful out there today. All kidding aside, we're all happy for her. Okay, we tweaked this both ends to where we're square. Now we're ready to go ahead and weld up the bottom side of these. We're going to get enough penetration where we're going to grind this flat again, because this plate is going to go against the mounting plate on the top of the pilot house. I took one of the angle plates off of the back there for supporting because we're not drilling right now. So I brought it over here, bolted it down to the table, put a clamp on it here so that we can hold this bottom plate in the vertical position here in relationship to the horizontal of the tubes. And now we can do the welding on here. And then after it cools down, because it's being clamped in this position, it's going to hold that position. If you freely weld aluminum out in its own stress-free will, it will have its own will, and it'll travel and it'll warp and it'll go all over the place. But if you hold aluminum in its position and you weld it and it cools down, it will stay in there. Also, if something is warped, you can clamp it where you want to, and then you can heat areas in between your clamp and support areas that you want to manipulate, meaning heat them up, let them relax, and then let it cool down and it'll hold again. That is the process that I would go about straightening something that was out. Um, Anyhow, back to it. Now I'm going to finish getting the rest of my welding gear, and we're going to weld up these seams right here. And I'm I'm going to start at the bottom and do a vertical. It's a lot easier to do a vertical than any other. You can't come downhill, or we're not going to have to tip this up and lay it flat. So I am going to choose to do a vertical and start down here, and I'm just going to build that up. Now, this has actually got a pretty good gap over here. I mean, watch how far I can bury this pin in there. Okay, so that's at least 3/16 of an inch open gap here. But we're going to start down here, and we're going to fill that in. It's going to be pretty easy because this is a piece of 1/4 inch right here, and we'll concentrate the heat over there. But we're going to be welding on top of the puddle. So, and then once we get that filled in, we'll be able to grind it flush. And then when we stand it up and we weld on the other side there, it'll be easy because it's going to be full of material. In fact, the material hopefully will be in on the other side. Like everything else, we're trying to get full penetration where we want the penetration. All right, I got you under your new lens here, and I got a piece of rod here, and we should be good to go. Let's see. Really sounds like you're inside that pipe, don't it? Okay. Now let's go around the other side. two little spots in there that I want to make sure. See how it hollows out right there a little bit. And okay, here's the small one, and let me just show you how I can stick the, there you go, okay? It's wider than my 1/8 inch TIG rod. And I'm changing my sitting position here a little bit. Okay, let's see what we got here. Let's grab a new TIG rod here because I don't want to run out in the middle of everything. Okay, let's see if we can do this. Ah, there you go. All right. Just so you know, I accidentally touch my tungsten every once in a while as well. All right. Now, I stop and I'm going to clean my tungsten, and then I'm going to grab a wire brush and I'm going to clean that. We're good to go again. Sometimes you got to let it cool just slightly so you can come back in here. Okay. All right, we're going to let that cool there, and then we're going to pull this off of here when it's cooled down, we'll be able to bring it back to our jig here, and we're going to move on, and we're going to finish the rest of our holes for the cross connect for the electrical wiring. All right, we finished all 4 of our straight through holes, and then we deburred them. We took and we wiped this down with acetone so that we had capabilities of putting in a weld on the outside of the tube on each one of our stays. Now, I have an eighth, it's moving a 1/4 inch on each end, okay, but that's 1/8 twist, 1/8 of an inch, 1/8 off one way, 1/8 the other way. When you measure it like this, that's a total of a 1/4 inch. So we're going to clamp this down, and then we're going to do all of our welds on this side. We're going to turn it around so we're comfortable, and we'll clamp it down again, and we'll do all the welds, and then we'll see how much we're able to take and correct that amount of twist in there. Whatever we have at the end is what we're going to live with. We're happy with this plate, and we ground this surface now so that we're flat and flush right here, and it looks super good standing up on the table. So it is straightened up. It does have a slight little twist, and we're going to try to take that out now, plus put our second weld on each one of these. You know, if I had a professional weld pin table, I would not need a K&T. Just finished welding down this side here, and I was able to remove about half of it, okay? So I'm gonna go ahead. Okay, I'm gonna flip this thing and get it in the other position and weld the other side. We just released it after doing this small end. It's still pretty warm. I'm getting a total of about 50 thousandths movement there. So we have really cut that down to minimal. And we probably could clamp it down, preload it in an opposite direction, clamp this down and do some heating, and we could probably get it to be even less than that. But that is very minimal for 4 foot to be 50 thousandths out. I'm gonna accept that. Rebolted this down to the table, and now that we're welded solid down there, you can see she's real rigid. I've got the table kind of like at a little bit slight of an angle here. It still does run downhill, but right now I'm level across the bottom down here, and this one up here happens to be level. Some of these are actually twisted a little bit, and I'm not gonna worry about it. All right, now I want to slip the skin back on here and see how it fits back on here, and see if we're still close enough. And also we trimmed off our tops here flush with our line that we had scribed, and we want to take a look at that. All right, slightly sticking out the top, which is what it should be. All right, now we're a little bit long on the front here, meaning it needs to go in. There we go. That looks better. Looks good. All right, we're gonna wipe off all of our marks out here that we have because we're gonna be introducing new marks, which We're going to go ahead and break loose our tack so that we have a front shell and a back shell separate now. And this top plate right here, we may grind a little bit flush on the top and then go ahead and weld that shape right on the top. All right, we slipped our two spreaders in here and we got them leveled out, and from the front you can see a little bit of the gap in here on this side here, but you can almost get the straight on visual of the main mast and spreaders. There's still going to be a platform that comes out here for the array, and we still have the skylight that's going to be here and the Fruno plate on the top, and the antenna mounts and all of the other stuff that goes on this thing, the light mounts and that. But you can see how massive this piece is. But the vision I have, of course, the wings look upside down to a plane because the air draft usually is flatter on the bottom and you curved on the top, and that's what gives the airplane lift, because that air's traveling over and it has to go faster to get to the other side, and that's what gives the lift. There's a couple shots looking in at the cross section between the opening of the spreader and the opening of the vertical tubes right here. So we got 1, 2, 3, 4. All right, we're going to cut this video right here, and until next time, get her done.